Hello, everyone. I didn't understand most of that, but I think I made out New York City, and that is where I'm from. Hello, good afternoon. Thanks so much for coming, listening to me to talk about bridging the gap between module systems. How many of you out here use a module system for JavaScript? Okay, and let me just ask, how many of you write JavaScript every day? Okay, so I am in the category of writing JavaScript every day. My name is John Paul. I love JavaScript. I have a huge passion for it. I have dalliances with Scala and indiscretions with Clojure where I go out and write these other programming languages once in a while. But I always come back to JavaScript because for me, I'm finally able to, using JavaScript, build applications that my mother and father can actually see. You can find me online in these places. If you have any questions, you can let me know on Twitter now or otherwise. I just tweeted these slides at the CodeFest Twitter handle. So if you want to follow along with me, if you have your laptop, I know some of you do, feel free to go on there, click on the link, and this is all HTML stuff. Additionally, if you have any questions, this is a fairly, if you want to move forward and come here, I can see you all a little bit better, feel free. If you have questions as I'm going along, just raise your hand. If it is in Russian, don't worry, I will translate it to a question that I know the answer to, and I will just answer that. So don't worry. Okay, so I'll start off talking about script tag life. So life in a browser, life as an engineer in a browser is focused on being able to build applications by taking the libraries and tools that are already out there and standing on the shoulders of giants to make applications that we can give to our users, give to our bosses, and even make for ourselves that we can use and find actually useful. What this means day to day is we don't want to write all of the code usually to deal with cross-browser situations. We don't want to write all of the nitty-gritty, low-level primitive code that we can take from libraries or we can take from a lot of the open source community. So what do? We take bits and pieces from all sorts of libraries and put them into script tags. And those script tags end up somewhere in our HTML pages. And because of the wonders of browsers, all of this JavaScript gets executed and we can stand on the shoulders of giants and make applications where we don't have to remember how jQuery actually works, even though it might be worthwhile to know how. Similarly, we don't have to know how jQuery animations or prototype or how promises work. The promises talk is later this afternoon. Who's going? Okay, I think you'll all find it very interesting. There's a lot of low-level things there you should take a look at. So what this means for us in terms of development is, let's see if I can zoom in a little bit. So when we are actually starting to write code, we're in a greenfield project and we are coming up with here's our dependencies and here's our own code, we start off with a nice easy few script tags like this. We have a script tag called main.js. Our main.js file is where we put our own code. And what do we need in order to write our code? Traditionally, we use jQuery or we use a prototype or we use some library that gives us the freebies that we don't have to actually write every single day because we don't want to solve all of the problems there are to solve in a browser. So we start off with nice, easy code that looks like this. We have two script tags. Everything is pretty straightforward when you're in a new project. Then what happens is we move on to, okay, so we need to add a little bit more flavor to our sites. We don't just want to depend on jQuery. We want to depend on some jQuery plugin that someone else wrote from 2009 or something that you wrote as a jQuery plugin some years ago. And it gets a little bit more complicated. You end up with 3 script tags like this. But again, this is something that's possibly manageable and possibly something I've done hundreds of times in my career. But then your application gets bigger, more and more of these script tags get created, and you end up with multiple places where, first of all, you have to add more dependencies like Google Analytics or Chartbeat or whatever else that you're using that might be required in your page. And you have to move on from there. So you have jQuery, you have one plugin, then maybe you need another plugin, and then maybe you have multiple main pages. Instead of just one main page for your actual application, you have some landing pages that you need different jQuery on. And now we're getting into the, that's 6, 7 script tags, and you can still sort of read it and sort of understand what's going on, but it is becoming much less explicit where code depends on other code. It's hard to tell from this where different pieces of the jQuery or the jQuery plugins are actually needed just by looking at script tags. And we end up in places that look way more complicated. We end up in this very quickly, and really this is probably on the good side of very large server-side rendered applications, because eventually there are many people, more than just one or two engineers. Sometimes it's even the marketing groups of your company that want to throw script tags and throw image beacons and throw all of these things into your HTML pages. And you get really, really quickly into script tag soup. So I'm not going to feel bad about putting this up because I am the speaker right before lunch. So if this is tantalizing to you, feel free to look at it and get hungry because you'll be eating as soon as I'm done talking. Okay, so let me zoom out here. What I'd like to talk to you about now is moving on from a script tag life, where most of our applications composition is contained inside of the order of all of your script tags, where if I went to something like this and I changed the order of one of these things, no one can tell what I'm actually breaking. What a module system does is allow us to specify explicitly inside of our code what depends on what. Does this particular bit of code need just jQuery? Does this particular bit of code need jQuery and a plugin for maps? A module system allows us to explicitly write all of that into our code, so there doesn't have to be any more guesswork around which script tag should belong before what other script tag. There are a few different flavors of module system, and many of them are competing. So how many of you use Require.js? I think I might have asked this earlier. And how many of you use Browserify? Okay. Wow, there are some very tall hands for that one. Okay. So I'll go into this a little later. I use both. Currently, Browserify is the tool of choice for me. But so let's start off with AMD. AMD is the asynchronous module definition. This is a specification for how to load separate JavaScript files as modules into a web browser. This is a specification that happened a while ago, and there are a few implementations of it. But what this actually looks like in terms of code is a way to define, let me zoom in here as well. In AMD, which is the asynchronous module definition, you can define a module like this here called point. And the module point is defined by calling this special function called define. Define is a special function defined as a primitive in the AMD specification. When you call that with a specific name, you can return something out of it that becomes the value of this whole module itself. So if you put this particular piece of code, lines 2 through 8, into a file called point.js, that can then be utilized later by explicitly, in another file called myapp.js, I can explicitly depend on this thing called point. Rather than having to make sure that the script tag for point is here and somewhere below in my list of dozens or hundreds of script tags, my app file has to be there after that. I can specifically define it here, and then the module system itself will know, because John has put point here, it means that point is depended on, which means I have to put, when I actually bundle up my code all together, the module system will make sure that point exists above the myapp definition inside of the output file. So this is how AMD looks. And AMD is this syntax that is implemented by two different popular libraries. One is Require.js. Require.js is probably the most popular AMD loader by far. Additionally, there's curl.js, and there are many other smaller AMD loaders out there that you might come across. All of the goal of all of these are to build is to build applications using this kind of syntax, such that you can define your dependencies as strings, and your module system will go and make sure that everything is in the right order for you. You can use these two tools to accomplish that. So after AMD, there became something called CommonJS. CommonJS has exactly the same goal as AMD. The goal is to be able to explicitly define your dependencies and say, I depend on this other thing in this file, so make sure that that thing is defined before I actually get to execute this piece of code. CommonJS happens to also be the node the module system that Node uses, with a little bit of a variation for Node modules to work exactly. But how CommonJS works, it looks actually extremely similar to the previous one. The previous example had that special thing called define, and define came from the AMD loader itself. Here, there's no special function that you have to call in order to define a module. You just have to make sure that you have a file name that can then be used somewhere else. In this example, I define a function called point, and I actually assign this to a special thing within the CommonJS specification called module.exports. Module.exports stands for what this module itself is actually defined to be. So here I set module.exports to point, and then when I actually require that in my app, this is an exact parallel to the previous AMD example, the CommonJS system, in this case, in the case of this example, Node.js would know, since you're looking up this path, I'll go look in this file, and I will take the module.exports from there, and I will assign it here, and then you can do whatever work I want. So again, this accomplishes the same goal as AMD. I can explicitly state what I depend on that happens to be included somewhere else. I don't need this to be encoded somehow in the order of script tags, and I can then use that piece of code to actually do something. So what questions do you have? I don't know if I'm seeing any confused looks. Okay. So the two implementations of this, the two biggest implementations of this are Node itself, Node.js, the platform allows you to write code like this, and additionally Browserify. Browserify happens to be my tool of choice when it comes to making module systems or working with module systems for client-side code. What Browserify allows you to do is write code that looks just like Node, like this, and you can bundle it all together and make a single script tag, or make a single file that you could then include in a script tag for your application. Another power of Browserify is that it easily allows you access to all of the thousands, if not tens of thousands, I actually don't know the exact number, of modules that are existing on NPM and liberally licensed for you to actually use. So you can go onto NPM, find the things that you want someone else has probably built, NPM install it, and it all works really nicely. Browserify gives you that ability. But actually, other things do as well, and I'll talk to you about that a little bit soon. So there are a few more than this. There are other mythical beasts in the category of module systems for JavaScript. There's AMD and CommonJS, which are the two big ones that you've probably heard of. But mythical beast number one is UMD. UMD is the universal module definition, and it allows you to write modules that happen to work in both CommonJS and AMD situations. But the way that it works is actually really complicated, ugly, and in my opinion, clunky as hell. You can add in your JavaScript on top of any module that you're defining, you can add all of this boilerplate right here. What this code is doing is actually checking, am I in CommonJS situations? If I am, wire everything up one way? Am I in an AMD situation? If I am, wire things up a different way? Am I in neither of these situations? Should I just be adding to the global like old school scripts used to do? Well, I can do that too, and that's what's happening here. So this piece of boilerplate that sits on top, this piece of boilerplate that sits on top of all of your UMD modules allow a pretty extreme form of flexibility. You can actually write modules that work with both CommonJS and AMD, but you have to sacrifice this particular big piece of chunk and readability for it. So mythical beast number one, UMD exists. It is a possibility for you if you're trying to write libraries that you want to share easily across many, many different places. UMD has many patterns underneath it. This is one of many patterns. Adi Osmani and James Burke actually keep track of all of these things on the slides. If you want to take a look at this link, there are many other patterns that you can see. They've written up a few blog posts about it as well. Okay, so mythical beast number one, UMD. If you want to do this, it all works really nicely, but it is pretty complicated to understand. Additionally, mythical beast number two is native modules. So ECMAScript 6, if you were here for Axel's talk earlier, you know a little bit about ECMAScript 6, which is the next version of JavaScript. It's currently actually being implemented by browsers and implemented by JavaScript engine vendors, but it is not, and the specification recently completed, but it's not actually widely available yet. But you can actually go through the process of transpiling, meaning taking code that exists in ES6 and taking it and putting it back into versions that you can actually use, like CommonJS and AMD. You can build using ES6 modules. Here's exactly the same example as before. I have a point. I use this special thing called export default, which is the equivalent of a similar equivalent to module.exports in the Node world or the CommonJS world. The next version, ooh, this. Oh, I thought this is, I'm just going to read this whole thing. Hold on. So point.js line number 2. No, no. Okay. So this example that you can probably see over there is just another as an example of ES6. And in ES6, you can write modules just like you can for CommonJS. And this is actually the module system that's going to be built into the language. So down the road in the future, there are actually migration paths, very straightforward migration paths from all of the modules you've already written in CommonJS and all of the modules you've already written in AMD to automatically transpile those into the module system of the future. This is where we will be in a few years. But right now, the specification was recently finished, and right now all of the translation processes are still being worked on in order to actually start building like this. If you want to start trying, the only right now production situations where I've seen it actually being used is the Ember core team, but there are internal to companies a few places where people are trying to start writing in ECMAScript 6, including ECMAScript 6 modules. If you want to try right now, you can Google for the ES6 module transpiler. That will allow you to write code that looks like this, which is the new module system for JavaScript where we're going to be, and it will spit out CommonJS or AMD, depending on whatever module system you use today. You can include those files into your application. Now I kind of wish that it blacked out so I could pause to drink some water. So hold on a second. What questions do you have? Yes. You have a mic already. How lucky is this?
You can use AMD only in browser, and you can use CommonJS on the server side via Node and on the client side via Browserify. So what is the reason for UMD? What is the benefit of AMD
So
comparing to the CommonJS?
Sure. So AMD. So the first thing that you said is actually incorrect. You can write AMD that is used on the used in Node. So using a program called AMDefine, AMDEFINE, you can actually write AMD code. That's actually how Markdown, the Markdown parser, the most popular Markdown parser in Node, is actually written in AMD because it was built for the browser. I believe actually before Browserify was very, very popular. And using this tool called AMDefine, it then runs all of that in Node. So you can write AMD to run on the server side. First thing. So why UMD is useful is for library authors that want to be able to, without any shimming, use small snippets of code across many, many different platforms. So while you can write, I'm actually going to describe that a little later in this talk, you can write pieces, you can shim almost anything to include into require.js world or Browserify world. But if I'm a library author and I want to share my my factorial function because I think my factorial algorithm is the best thing ever, and I want this very small piece of code to be able to be used across both NPM and Bower and wherever else you might want to get that, it might be worthwhile for me to be doing the overhead of, me as a library author, to be doing the overhead of mapping everything out rather than leaving it up to the end user to say, you can wrap my factorial function for your tool set and you can wrap it for your tool set. That's why UMD exists, to give library authors that power. Any other questions? Okay. Okay, So another big question here is where to find modules. Where to find modules in the JavaScript ecosystem is sort of a very complicated question because there are so many different places now that you could go to find JavaScript that you can use, that you can build on, that can make your life a lot easier. There's NPM, Bower, and Component, which are probably the big ones. NPM is what I use most frequently to find modules that are already out there in the Node ecosystem. Additionally, there's Jam, JSPM. You can download things like jQuery UI and say, I only want modals, but I don't want tooltips. And you can do similar things with Twitter Bootstrap. And then there's this other thing, which is just random JavaScript you have that you wrote a long time ago, or some JavaScript in prototype that you found on old hard drive that you know still works, or jCarousel Lite. Which has anyone used jCarousel Lite? Am I the weird person there? Okay, good. I'm not the only crazy person. So there is a particular carousel library that I know very well and I've used for many, many years. This is not on any package manager or anything like that. It's been tried and true for me, but I have a script file. I have a JS file that I really enjoy using. So there are all of these different options, and really you can look at this and get a pretty big headache trying to figure out where is appropriate for me to get these things from. But I'd like you to think about this a very different way. Usually people look at this and think, oh man, we just need one. We need to centralize. I'm tired of all of these different places. And really, for me, myself, I'm usually NPM. But I don't look at this badly. I look at this like I just won the lottery. This means that there are so many more places where library authors can choose to publish what they've written that I can then use because I don't want to write all of the code that's out there. I want to let library authors do what they want. And I want to be, I know, I'm glad that I got one cat animated GIF in there. I want to be as flexible as I can possibly be to give them that option. Library authors are people who have sat there liberally licensing a lot of their very hard work. And I'm very happy to be living a life where no matter where they want to publish, no matter what module system they're using, I can always stand on the shoulders of all of those giants to build my applications. So how does that actually work? If you're using Require.js, there are a few different modes in which you can actually include code from other places. The first one is the shim config for global scripts. If you're using Require.js, you're probably familiar with this. I'll go through it in a second. And then there's the RJS optimizer, which is a script that you can use that Require.js publishes that allows you to bundle all of your different modules together into one script file. And it can do a lot of magic when it comes to modules from NPM. Oops. So the first one is Require.js paths and shim. If I want to, for example, this is the start of the talk where I subliminally use the word Ember a lot because I am a huge fan of Ember and I want you all to hear the word. So here the examples will start being about Ember and jQuery. So if I want to use jQuery and Ember, neither of these things which are actually part of the AMD ecosystem, although jQuery is now, but Ember is not part of the AMD ecosystem. Using this kind of configuration, I am allowed to define, taking from Bower in this example, Ember, I can download Ember from Bower, and I can download jQuery from Bower, and I can specify in the paths config of Require.js, the paths shim of Require.js config, I can say jQuery lives in this file. This file could be coming from Bower. It could be coming from some JavaScript file from a long time ago. It could be coming from JSPM or anywhere from the internet that you find some dependency for. And then you can wire them up using the shim, which said this particular piece of configuration says that Ember depends on jQuery, so make sure that jQuery loads first in the script tag order, if that actually existed, if you were back in that tag soup type of scenario. And then the global variable that this particular script file exports is capital Ember. What this allows me to do, once I have this nice configuration written up that says, module system, I'm trying to use something that doesn't obey all of your rules, but I will give you rules that actually map correctly. Once I do all of this, I can use in my application just Require Ember and jQuery as if it were a normal part of the AMD ecosystem. So using this, I can take pretty much anything from the world of JavaScript on the internet. I can include that into this pads and shim config, and I can then use it as if it nicely fit into require.js and AMD. So this is how you can take in almost anything from that list of big package managers, except npm. Because npm, you want to just npm install something. Which an npm install is the command that you use for the Node package manager to say, go get me jQuery, go get me Ember, go get me these other things like that. The way that you can do that is, for example, if I wanted to install Euclidean distance, which happens to be something that I searched for on npm, and I want to calculate the distance between 2 points here, I can actually use npm install, and this line right here makes a lot of life a lot easier. You don't have to go and find a JavaScript file, copy it into your repository, commit that file in. You can just type this command and it'll automatically install into conventional directories in your application. Then, in order to use with require.js, because all you did was type this special command, you didn't actually put the script tag anywhere, you didn't configure some shim or pads config, using the require.js optimizer, which is this special script right here that comes packaged with, if you download require.js from the require.js website, you also get the require.js optimizer. If you try to run this command, which will compile together my app and spit it out into this file called myapp.build, what the require.js optimizer will do is, first it'll look at all of your dependencies in my app. It will look up point. And point, as I just showed earlier, that's actually a file on the file system. So it will include that in the right place in the order of all of the script tags that need to show up, or all of the JavaScript that needs to be defined. But when it finds Euclidean distance, it will go through that process and see, oh, you don't have any file called Euclidean distance on your file system. But the require.js optimizer is really smart, and it knows if you have npm installed something there, it can tell. So the require.js optimizer will say, I can't find Euclidean distance where you normally keep things. I bet you're using Node, and I bet you're using npm. So I can go and find that, and the require.js optimizer will bundle everything together. So you can just type npm install package, and then you can just use it very simply using require.js. So these two things, using the shim config and using require.js optimizer, with require.js, you can then pretty much take any library from anywhere across the world that has written pieces of code that you don't want to write, which is the best way to be lazy on the face of the earth. Okay, so if you're using Browserify, let me check the time. So I'm going to speed up a little bit. If you're using Browserify, there are a few helpful transforms out there that can allow you to do the same thing. Take anything from anywhere and build it into your ecosystem. These helpful, so a Browserify transform is just a black box that converts some input into some output. It can take some source code, transform it into something else. So a typical example of what a transform is if I want to using Browserify a CoffeeScript transform, a CoffeeScript file will come in and a JavaScript file will come out, and that transform will just take one and run the compiler and then spit out the other side. Additionally, what Browserify transforms can do are take code that are in one module system and automatically convert it into another module system. So in this case, I can use this thing called DAMDify. DAMDify sounds like what it does. It takes code that is in AMD and will automatically convert it on the fly to CommonJS. So if you have an AMD module that you have already written or that you found somewhere on the internet that you want to use in Browserify world, you can just run this. You can run this command using this special transform, and it will convert AMD directly into CommonJS for you. Additionally, after that, does this zoom a little bit? Using Browserify shim, I can do something very similar to what I showed earlier using the require.js shim. Browserify shim is another transform, similar to DAMDify, that allows you to write code that looks very similar to the previous one. I can say, I found jQuery from here, I found Ember from here, happens to be in Bower, not in NPM. I can configure it very similarly to the previous. I have jQuery that exports a $sign. I have Ember, which depends on jQuery and exports this capital Ember thing. And then inside my main file, which is little cutoff here. I can actually require these things just like I would normally, as if they were part of the Browserify ecosystem, even though I'm getting them from Bower. The goal here in general is to be able to take code from anywhere and use the whatever module system you're using to actually use that code. Okay, the last option here is in case you're actually working with something a little bit more greenfield, if you haven't already made commitments to Require.js or Browserify, there is a relatively newcomer on the block made by Kyle Simpson Young called the Webpack Module Bundler. The Webpack Module Bundler is very similar to Browserify, but it has first class the things I described earlier, which is being able to load code from many different module systems directly within their own configuration. Additionally, the Webpack module bundle allows you to write asynchronous modules using CommonJS syntax. So I can write code that I want to load sometime later in the future. I can write that using the Webpack module bundler, and it will automatically split out multiple bundles for me and say, when my user first goes to the app, I only need the first script tag, but when they click on the shopping cart, I can suddenly load all of the shopping cart code later, which is really useful when you get to big applications that have a lot of JavaScript that you don't want to send over the wire. Okay, so I want you to think about embracing dependencies across the board. This image that you also can't see the bottom of is basically showing how excited I want you to be about being able to depend on other people's code. How many times have we actually never wanted to write something? For me, I try to wake up every day thinking I thought I had to write code for the browser, but then I didn't have to. Because writing code for a browser is actually really annoying and really complicated if you have to fix all of the potential problems out there. I don't know how many of you have experienced that, but most of my life has been wrangling with the browser. But when I find that someone else has done that already, I can take a step back and I can breathe a sigh of relief and think someone else out there has already liberally licensed what I can take and I can build on top of to make something even greater. And this goes a little bit further than just JavaScript and just the world of module systems for our applications. It goes all the way to the extensible web manifesto. So the first thing I want to say about this slide is that I really enjoy, I don't get the opportunity to use very creepy animated GIFs like this. So I hope you take heed and take advantage of the fact that this is very scary. But I want to talk to you about the extensible web. So how many of you have heard about the extensible web manifesto? Okay, so I want you all to take a look and Google for the extensible web manifesto. Where we are going, we are more than just JavaScript authors or module writers or people who use module systems. We are actually engineers who together build the web platform. We are doing so much more than just piecing these things together. We are building the way forward for the future. The Extensible Web Manifesto is a group of people that have together decided that are on many different standards committees and standards bodies who have decided that we want, as developers for the browser, to have access to a lot of the low-level primitives so that we can make. So right here, I was just talking about how to write code that utilizes JavaScript other people wrote. There are new features and new specifications like web components and shadow DOM and HTML imports and all of these things that allow us to take much more than just JavaScript. Eventually, you can be building DOM elements that I can then take and use in my application, or I could be building them that you could use in their application. We are building a platform that is much more than just JavaScript. And once we have the ability to make these kinds of shareable widgets and these kinds of reusable, self-encapsulated things, our lives as engineers will get exponentially easier than even what I'm talking about right here. So I want you to focus on the fact that we can always be using code that other people have written to make our lives easier. Down the road, we can be taking much, much more than code. We have to be thinking about ourselves as builders of the web platform, because moving forward, we have a lot of work to do that we can actually do. Google for the Extensible Web Manifesto. Talk to me about it afterwards, because I'd love to talk to you about how we're going to accomplish all of those goals. And what questions do you have?
Oh, hello.
Hello.
The nice talk, really comprehensive information. I liked it. And so my question is, why you didn't cover the testing module topic?
Testing modules?
Yes.
You mean how to mock out modules?
No, how we can test the model, why we use the model system, and how it can help. It can help us to create something we can test.
Sure, I mean that's a good point. Why I didn't talk about it is because it does not work with the goal of building on top of other people's things. But that's true. So what he's talking about is once we have these modular systems that are not that explicitly define dependencies, a huge pro of that is not just that we don't have to worry about script tag soup, but also that since we're writing modules that we can have a well-defined interface, we can then write tests for those modules much more effectively.
Yes,
I agree with you.
It's very important to test the code which we write, and so if we can use just a Grunt or Gulp build system to create just a pack, just concatenate our JavaScript, but we can test our modules, our plugins, jQuery plugins, because we have no explicitly interface API. So
I agree with you.
yeah, nice.
Hello, what do you think about dependency injection in Angular JS? It's very similar that you shows in AMD in Require JS.
So Angular modules, I'm not an Angular expert, but so in order to make Angular modules don't actually explicitly define dependencies from files. It doesn't solve the problem of a module system. If you have all of your modules loaded using Angular, then its dependency injection is very nice. But it doesn't solve the problem of script tags, for example. You have to make sure that all of your code is loaded before. So they solve very different problems. We can talk about it afterward for more specifically.
Hello. What do you think about that in ECMAScript 6 specification written that I'm modulus, not load async, and all modules must load synchronously?
I actually thought that using the system loader, you can define that yourself. I don't think that they say across the board that all modules have to load synchronously. I believe that is a choice that the user agent or the developer could make. So I'm happy with it, I guess, in general. Okay. But to be honest, I have not written. The ES6 module transpiler does not support all of the possible use cases yet of the ECMAScript 6 module specification. So once that is there, I can more explicitly address that. But so far I am comfortable with believing that I can address all of the use cases that I've had in Require.js with this.
Thank you.
Sure, thanks. What other questions do you have?
Hello. Oh, hi.
Hey.
I didn't want to ask a question, but anyway, some time ago, probably 6 months ago, we were sitting together in bar with one guy from Opera and one guy from Smash Magazine. You know, all the best conversation take place in bars. So anyway, and we found the idea of adding the most popular libraries and frameworks right to the browser and update them easily with the browser's updates. Because right now, you know, we don't have browser versions. So for me, it looks like the nice idea, but some guys on the internet found that it's not the best idea, so on, so on. So I want to know your opinion on this topic. So,
I don't think I've ever thought about it before. So it seems like, so in order to do that, you would have to make some syntax in HTML that allows you to make that work somehow with older browsers, I'm assuming. That it would know to parse this specially to not go get it. I don't live a life of mobile very often. Most of my life is building client-side MVC applications, which is a one refresh and then sit there for days. So I don't particularly have that problem. But my thoughts are mostly about backwards compatibility and if you can actually make older browsers do what you just described, but I have not thought about it at all. I will pull off thinking about that, especially because you didn't even want to ask the question. I will come up with a way to answer, I'm sure.
Okay. So next question is about CDNs. So to use or not to use, because probably some days ago there was an article about the CDN as bottleneck, you know, because we have China, we have a lot of countries that are like the wall against the internet. So, what's your experience with CDNs and
Do you mean
loading modules from CDNs and so on?
Do you mean the public shared CDNs or private CDNs?
Anyway, doesn't matter.
Oh, so private CDNs are great. I would definitely recommend, if you have the traffic to push, if you have the traffic and the money to push everything to a CDN privately, I would recommend that extremely. It is most CDNs have a way to split out number of domains if you need to make multiple requests, if you have to have many script tags at the same time. And moving to a CDN such that you don't have to send cookies over the wire for all of these static resources is a great reason for that as well. The public shared CDNs are a little bit of a different story in the sense that the usual argument for why you should be using a public shared CDN is that you will probably get a cache hit. But in actuality, that's not true when it comes to actual statistics and research. So a public shared CDN, I have no particular preference for either way. I have not used one in a long time. I used to. But a private CDN, I think, is very, very useful, especially when you have performance problems and you are JavaScript heavy, or you are JavaScript heavy or static resource heavy.